So I'll take the next 30 minutes or so to talk about why I thought, or we thought, it was a good idea to focus on cities, given that we sit at a university and a Department of Energy laboratory, and how that's relevant to the things that we do in general. And then I want to just walk through the strategy that we're taking in terms of urban science research, some of the opportunities that have been springing up around the science community around cities, and some projects that we've been doing with the city of Chicago primarily, but increasingly lately with other cities as well. So I guess when I first started thinking about cities, somebody showed me some work that Karen Cito had done at Yale, looking at Landsat images, in this case the Pearl River Delta. On the left-hand side is the Pearl River Delta back in 1980, and the right-hand side is 2005. So in terms of the impact on the planet of urbanization, it's kind of, sort of visible from the satellites what happens when 40 million people get together in a particular place like this. Has a significant impact on climate, energy supplies, and things like that. So, from the point of view of the university or the laboratory, we see an opportunity as we have, and I'll show later how we've been interacting with the urban design community. We see an opportunity of using computational sciences and data analytics to help these guys do a more effective job of planning the next generation of cities that are being built, and to use China as an example, quite rapidly being built. But cities are also, not just about the infrastructure, but they're about the people that live there. And so other opportunities looking at cities have to do with the more social, economic, and health aspects. So here you see these color-coded maps of Chicago in terms of life expectancy in years. And it's quite striking that if you live in some parts of the city of Chicago, you have a chance of living a life that's 14 years longer than if you lived another place. And so we would like to understand why that is. And if we understood why that was, then there may be policies that cities could put in place with existing infrastructure and services, or it may guide the design of the next generation of cities that are they're going out there. So Oakland is no different. So this is in lots of cities, not just Chicago. So the research program that we've sort of arrived at after a couple years of, I would say, opportunistic finding of projects that come from cities, and I guess by way of background, the first thing that we began to do to put together this kind of research program was to sit down with people in the city of Chicago, commissioners, the CIO, the Chief Sustainability Officer, people in charge of buildings and transportation, and first of all say, we're not looking for money. That always kind of made them feel a little more relaxed talking to us. And then to say what we want to do is we want to do research in urban sciences in understanding cities, but we want to do research that's relevant. So would you tell us about the kind of challenges that you have both short-term and long-term? And so that has really helped our thinking about a research program by interacting with city officials. And we've been, since that time, we've got partnerships now, significant partnerships with San Francisco and Memphis, and partnerships at various levels with other cities as well. So we're finding ways to take some of the challenges we learned about in Chicago and find common ones in other cities, and vice versa. When we think about urban science, the thing that you see here on this is a 3x3 matrix with some impact at the bottom. There's almost no challenge that a city has that falls within one of these three verticals. And in fact, a lot of the challenges that cities have come from doing work in one of these verticals without thinking about how it impacts the other verticals. So, if you have an environmental disaster or problem due to infrastructure, well, maybe it's because the people that built the infrastructure weren't thinking about the environment. I heard somebody recently say that, so how many people are from Chicago or familiar with Chicago? Okay, so if you were to head out of Chicago to the south, you would take the Dan Ryan Expressway that goes through the south side of Chicago, which is where the manufacturing base was 100 years ago. And so it's the old established neighborhoods of the city. And I heard a social scientist describe the Dan Ryan Expressway differently than, so let's say, a transportation person would. Transportation person would say, we put the Dan Ryan Expressway in, we reduce commute times like this amount through the south side of Chicago, and isn't that great? But this person who studies the neighborhoods on the south side, he said, when the Dan Ryan Expressway ripped through the south side of Chicago neighborhoods, so to make the point that an infrastructure project can have significant social impact. And in fact, if you look at the problems of the south side of Chicago, they're not just due to the Dan Ryan, but the Dan Ryan certainly wasn't something that promoted health in those neighborhoods. So what we want to do is we're looking for projects that span these three areas, or for projects that don't, and then add these other projects that are looking at just infrastructure. And I'll give you an example in a moment, but we want to add to that some consideration of people and environment. So we bring scientists into that project where they might not have been there before. And then we think of our projects and then the tools that we apply to these projects in terms of the time scales at which the effects of the project unfold or at which you can work. And so when it comes to designing or planning a new large-scale project, we want to use computational modeling to forecast what will be the impact of that project over years or decades. In the middle part, there's a lot of things that you want to do in a city to look at the information that cities are collecting and in some cases publishing. And so these are where you make decisions that might have an impact over days, weeks, or months, and whether that's changing a traffic pattern or changing the way services are deployed, that sort of thing. So data analytics would be what we focus on in that middle part. And the bottom part, a lot of cities, in fact, if you think of if you look at the smart city movement around industry, and they really have focused on things like parking and potholes and other things, which is fine, but to do that, to look at traffic through a city and respond to an event, for example, you need to have an awareness of what's happening on the ground. So we're looking at urban sensing, and I'll talk about a project there as a way to get more information about the city and through a variety of different types of sensors to give you different types of information about what's happening on the ground in real time. And we want to take that same project and take the other opportunity, which is to look at information services that are embedded in the infrastructure, hyperlocal, and ask the question, what sort of new services or interactions could be enabled if you put stuff, communications, computing right into the infrastructure. So I'll talk about major projects in all three of these areas, and starting with the urban design. So we found out a couple years ago, this is on the south side of Chicago. It's about 10 miles south of the Loop. It's a 500 acre, or 500 buildings site. It was the US Steel plant. So it employed 30,000 people until about 40 years ago. Now it's been a brownfield ever since. So we found out that this project had been approved to move forward. They got $100 million of tax increment financing to build out an infrastructure. So now Lakeshore Drive goes through the site. There's parks going in, and a phase one of 100 acres of residential, mixed residential, retail, commercial, and a high school. So we found out this project was happening. We talked to the developers and the architects. The architects are Skidmore, Owings and Merrill. If you've seen towers like the Burj Khalifa in the Middle East, or Petronas Towers in Malaysia, or Freedom Tower in New York, Trump Tower here, Willis Tower, these are all Skidmore, Owings and Merrill designs, but they also have an urban design practice. So we work with them to find out, how they were designing this. And we quickly found out that the industry of urban design is all of their tools and all of their processes, like the way they work together, has been honed over, a century or more around the notion of building a single building or a small number of buildings. 500 buildings is way outside of their experience and outside of their process. So we found early on that they were struggling with how to do this, how to anticipate what would be the impact of different decisions that they would make. In this diagram on the left, This is from their site plan. We also found out, by the way, that they had ambitious goals for the site. Don't have to own a car to live there. All the stormwater will be cleaned and put back into Lake Michigan, whereas if you know the history of Chicago, all of the stormwater now goes into the Chicago River and then eventually down into the Gulf of Mexico. And then they said, we want to use renewable energy for the site. So we asked some naive questions like, well, how do you know that you won't need to own a car? Or how do you know that you're not going to poison the lake every time there's a large storm? And they essentially said, well, we don't, but we hope that our plans will result in this. And then we asked, well, how much energy do you need over the next 50 years as the site will be built out over a few decades. How much energy would you need in order to power the site? And they said, and they pull out a spreadsheet, which is already just a little bit surprising. And on the spreadsheet, it started at, I think it was 6 megawatts in 2020, and it ran up to like 50 megawatts over 20 or 30 years. And I'm not going to tell you where they got those two numbers, but you could probably guess that they pulled them out of something. So we said, why don't we work on a project with you where we could take this design on the left. It's color-coded by zoning. So that's something the developer has some control over. And then in the fine print that you can't read, that's a projected date that part of the site will be built. And so it'll be like, one of them would be 2025 to 2030, another would be 2030 to 35, et cetera. So we said, what if we take those two knobs, right, conceptually speaking, down at the bottom, and gave you as a developer the ability to click on a building or a set of buildings and change the zoning or the phasing of that site, and then see what your energy demand is going to look like over the course of, say, 30 years. So they said, that sounds great. So we actually took this, we have a working system. This is mock data here. That's actual data up there where we mapped energy intensity to the buildings. There's a lot of assumptions you have to make about the efficiency of buildings, about the weather and the climate, about the buildings, the height of the buildings, the volume of the buildings for something that hasn't been built. But we tried to take a fairly simple case. And so the developer now has this tool. It's based on Esri's city engine. And then in the back, when they make those changes, we spawn 500 energy demand models for the 500 buildings or the ones that are in place at a given year over that period of time. And we take historic weather files and use that weather for the future. And then just recently we've been able to put in a way to say, well, we think that the 20 years, 30-year storm, or I guess 50-year storm will happen every 12 years, and the Arctic vortex that we just had last winter is going to come every 7 to 9 years instead of every 20 years. So we have a way to take historic weather and then essentially use that as 24 years of 12 months. So we now have 24 potential Januaries, and we can statistically assign those over the next 20 years for a scenario of weather. So this then gives the builder the ability to do some amount of understanding the sensitivity to energy demand of the decisions they're making. We also have started working with our transportation modeling people, a little bit more complex problem because you now have to know where people are going and where they live and where they work and other sorts of things. To be able to do this same thing to say, well, if you change the zoning or the phasing, how's the traffic look on Lakeshore Drive? Or if you put in bus rapid transit and a train, how's the traffic look now? So we think that there are opportunities to bring existing computational models together with urban design and planning, and it means rolling up sleeves and getting the data to put into the models and using those models. So not new computational science, but a new area for computational science to have an impact. So that's the long-term stuff. In the middle of the 3x3 matrix that I showed you, the data analytics, a lot of cities have been publishing data, and their portals, in the US anyway, all look like the one in the upper left because they're all using a cloud service called Socrata. And in Europe, they tend to use an open source system called CCAN. So if you want to write software to go and get data out of city portals or county or state portals in the US and Europe, you pretty much have to just talk 2 languages, and you can begin to build tools that go into these new sources of data and pull out information. The first wave of those kind of tools, a lot of work in Chicago, are things like you see at the bottom here in the middle of the left there. That's a snapshot from an animation of the snowplows as they move through the city. Because not only is the city publishing things like, in this case, this is building footprints. In the middle is zones. You can see business licenses, but they publish things like food safety reports, crimes. There's 600 or more, 600 to 700 databases in that portal. So the first wave of open data has been to do this kind of mapping, which it gives you some idea of what's happening in the city. It's not particularly deep insight. But in addition to the static data I was going to mention, all of the city's resources are GPSed. So every 20 seconds they know where the buses are, where the police cars are, where the garbage trucks are, snowplows, et cetera. We know where all the snowplows are today. But we might not know in a day in January at some point. So we went to the city and we said, give us your list of like the top things that you'd like to be able to learn from your data. This is now about a year old, but it's still pretty valid for Chicago and I think other cities as well. And I want to talk to you about some of the ones in red here that we first started with that really have to do with predicting the state of a neighborhood over a period of time. That became something that was important to the mayor of Chicago, Rahm Emanuel, and he didn't come up with this list here, but what he did say was, I would like something that would be like an indicator for a neighborhood that tells me I should do something because it's going in the wrong direction. In other words, the city wants to move from reactive policy to proactive policy. So, if, for example, if you found out that neighborhoods to be economically successful and sustainable need to have, 5 of the following 12 types of businesses need to be healthy in that neighborhood. And then if that was true, you would see a neighborhood that had 7 of them and then 6 and then 5, you would go, well, maybe we need to do something to beef up the economics of that neighborhood because when they hit 4, we know that they're going to slide. Might be something similar with noise complaints or crimes or 911 calls or that sort of thing. So looking for leading indicators is what we started working with the city on. We then got some NSF funding to do several things. One, the city is actually doing a pretty good job already of using predictive analytics for things like predicting where they should send their rat traps and baiting team. The rat patrol, they're actually called that. They go out and they bait for rats because any city with water nearby has a rat problem. And they've changed from going where rats have been reported to going where the data tells them rats are probably going to show up within the next week. Nothing magic, right? Source of food, moisture, dark places. So but it's a way to sort of systematize maybe intuition where you can't look at all the data they have just using intuition. So they have machine learning algorithms that do that. So we saw, stepping back from that, well, if you're say a policymaker, a sociologist, or an economist, you don't want to learn R or some other machine learning tool to be able to work with the city's data. So could we give you a way to just kind of look at the data that's there, find something that you're interested in, and then pull out the data to do your data analysis from. So just a way to sort of discover data in these city portals and then look at it and then pull it out. So we started with a software program that it's a pull-down menu of all the data sets that we've imported from the city's portal into a better geospatial database than they've already got. And then you can give it a date range and a spatial resolution, and it draws the map for you. The nice thing about this is you can get the map for the city, but you can draw a path through the city. So if you wanted to find out, say, noise complaints along the Chicago Marathon route, you could actually draw that route out and then you could get that data. You could draw out the route for a planned bus rapid transit and get data, economic data, and then come back after the bus goes in and compare and get data after the infrastructure is built and see if there was a difference. So, or you could draw a polygon or a simple square and then get the data just for that. What I don't have a picture of is What we allow the scientists to do then is to say, okay, now I'm interested in downloading the data for these 6 data sets, let's say, and I want it for this window of time. Instead of a spatial resolution for a map, we ask them for what's the sampling period that you want. You want daily data, you want monthly data, in which case we have to do not only some spatial decisions about boundary points, but also fill in data or extrapolate across those sampling periods, with the idea that the scientists would then look at that, graph it out maybe, and then pull it out and do some data analytics on it. We just took this software this summer. I had a graduate student that worked with data from the city of San Francisco. Just to give you another example, they have this sustainable systems project. It used to be called Eco Districts, but the Eco District people from Portland have trademarked that name, so they changed the name of the project, although it's similar to Eco Districts. But the idea is to give neighborhoods tools so that they can set goals in these 7 areas and then track their progress over time. So you have data like up in the upper right, and you want to somehow combine that data in an intelligent way to get these composite measures. To just zero in, this is from one of their reports, any one of these 7 areas will have a dozen or so components that they want to pull together in some hedonic model or what have you that would ideally be done by an expert in this area. So you don't want a computer scientist to decide what are the components of neighborhood identity. You want a social scientist to do that, even though the computer scientist would supply the tools to do that. So anyway, that's a city of San Francisco. Last summer, we did some projects with the city of, actually Cook County, the county that Chicago sits in. And then this summer, we're doing some projects with the city of Memphis. And the upper diagram, those are vacant properties rated according to several things we had students look at. So the context is that Cook County has something called a land bank. In the housing crisis, there are now 120,000 vacant properties in Cook County. So Cook County Land Bank is a semi-government organization with a budget, and they want to spend that budget to buy vacant properties back and either refurbish and sell or rent them, or tear them down and get rid of them, for the purpose of undoing the drag that a vacant property has on a neighborhood, increased crime, lower property values, and things like that. So our students then looked at these different impacts. They looked at 311 data. So 311, if you don't know, do you know what 911 is? There's an emergency, if a murderer gets out of prison and you spot him, you call 911. If it's a llama that got out of the zoo, you probably call 311. So that's non-emergency 911. So you call 311 if you want to report graffiti or rats or a light that's out or something like that. Noise is another example. 311, sort of nuisance service requests. So we looked at nuisance value of these properties. We looked at real estate transactions, median income, things like that, and gave the Cook County Land Bank a way to just get a general feel for, if you buy this property, here's what the impact will be on the neighborhood. Because ideally, you want to spend that money where it's going to have the most impact. So for example, the students found that if a vacant property is within 1/8 of a mile of another property that's not vacant, it has something like a 2% impact on property value. All right, so if your property is surrounded by vacant properties, your property value is just going to go down by some amount. There's some parts of Chicago where if you own a piece of property, there's so much vacant property around it that property is probably a liability and not even an asset. So that's not where you would start if you had a fixed amount of money to improve a neighborhood. You would actually go to a neighborhood that you'd look at neighborhood stability and real estate and other things and say, well, here you could actually make a difference with your small amount of money. In the bottom right, Memphis, we're looking with the city of Memphis at their infrastructure investment over the past 10 years and the next 10 years to try to make sure that that investment, as they move forward, has the best economic impact on the city. So they look at different ways that past investments have impacted city income or costs or that sort of thing. And then I'm just going to go outside of my own expertise and show a slide from a colleague of mine from Arizona State to give you like 2 examples where there's a growing number of people that are looking at data about cities and looking at it and saying, is there some fundamental principles or laws that are at work in cities given that we have this much data? So this is a project where Jose Lobo and these other folks looked at the labor pool for all 400 of the what's called metropolitan statistical areas. So almost every part of the US is part of one of these. We in Chicago are part of the Chicago, Naperville, Joliet, MSA. New York is Jersey City, New York, et cetera. So they looked at all of those. They color-coded 768 different labor types from the Department of Labor. They did this social network that had to do with how much you see those 2 types of labor together in the same city. And then the size of the ball is how much of that, how many people in the country work in that area. And then using that analysis, which I'm totally oversimplifying, not being an economist, they then looked at things like the four classes of MSAs, or say metropolitan areas. And the upper left is the lower quadrant in terms of the gross GDP per capita. That's a poor city, in contrast to the lower right, which are the more wealthy cities. So what you can take away from this is that you can actually look at the labor pool of a city and ask questions and answer questions that have to do with how productive is that city, and maybe guide a city as it's trying to recover or transition out of one industry to another to say, you want to transition from cars to biotech. There's probably not an easy path to get there with the labor pool you've got, but here's one that you could take maybe cars to something else. Some other work by some guys at the Santa Fe Institute that's kind of fun to look at. On the left, you can see that there's this scaling factor with wages and the MSA population. So those dots for the 400 MSAs line up pretty nicely on that scale. And so they've been looking at scaling factors for 20 or so different data sets about MSAs or cities. And then this is for mammals, so you see cities grow superlinearly rather than sublinearly like mammals do, like our heartbeat is slower than a mouse, for example, because of the mass. And then a fun project from the 70s, walking speed. So this is walking speed as a function of population, and you can see if you live in a bigger city, you walk faster, which I can only say from a few examples, I've seen that to be true. So I only have like a few minutes. I'm going to whip through one more project, which is something we're doing with urban sensing and embedded systems. So we have a proposal to the National Science Foundation from January, a major research instrumentation proposal. As of an hour ago, we hadn't heard yet back from NSF as to whether that's funded, but we got some Argonne funding so that we could push forward with a prototype of something that I'll show you a picture of, but imagine that you have a microprocessor or 2 and some sensors, and you put them up on light poles, and you have them publish the data every 15 seconds to some cloud service and locally through communications networks, and then you start to watch the city. So we got some, I'll say, somewhat irresponsible press coverage of this that called Chicago Big Brother, and I keep saying no. No, Big Brother is the city watching the people. This is the city providing data so the people can watch the city. It's the opposite of Big Brother. So anyway, some examples of questions that you might want to ask that you don't have data for unless you put sensors out through cities. We did this after doing lots of workshops like this, teaching people how to build these clever gadgets, and then finding out that to place these in a major city is a major effort because you need a protected place, you need power, you need internet, and you need permits, right? So we went to the city, they agreed for our project to mount our boxes at no cost, power them at no cost, and then the most important thing was go back every year and replace them or upgrade them. So we then do the hard work once, and every year we can put out the latest microprocessors, communication, sensor technology. That's the diagram of the inside. We have decided to do our own enclosure. This is a see-through one showing how it will go on a 9-inch street pole in the city. They'll probably go about 7 feet off the ground. That's a vacuum-formed plastic. We're working with the School of the Art Institute of Chicago, and we decided 10 days ago to make our own enclosure and throw out the commercial one that was ugly. And so this is after 10 days, they made the blanks and did this over last weekend. If you're here for a while and you have time to go downtown, I have 2 tourist suggestions for you. One is to go on the river architecture tour of the river that the Chicago Architecture Foundation puts on. The other is to go to their headquarters, where you can buy the tickets, at the corner of Jackson and Michigan. We have worked with them and others, including the city of Chicago, to put this exhibit together that will be there until September of 2015. So it'll be there at least another year. Our wall right here is on this project I just described, but there's a 3D printed model of the city, 1 foot, 50 feet translate to 1 inch. And we've got 6 projectors around the outside so that we can actually project data onto that 3D model and light up individual buildings based on whatever data you want to visualize. So we've been inviting hackers from the city to put their data in and display it in the model. So that's something worth seeing if you're going to be here for a while. So I'm going to stop there and take questions.
What are the ethical ramifications of telling a city to focus more towards one job than another?
So, this is a good general question, which is, if I could reword it, what are the ethics involved of taking data, doing analysis, and then advising a city based on that data? The stakes are pretty high. I could show you maps of gang activities in Chicago based on interviews with police officers and locals that have a concrete impact on property values. So there's a big responsibility to even mapping this data. I would say we wouldn't tell the city what to do. What we would do is give them tools so that they have a better ability to understand and look at the data. So there is responsibility in our tools that would be used to understand the data, that they tell the right story. And we think very carefully about that. But we wouldn't be telling a city, what jobs to do or that sort of thing. So the responsibility is more like, are we giving them good information, good data? And I think that's a responsibility all of us have in our work. It's just that you're not, with other sciences, you're maybe not talking directly to policymakers, but policy is made based on the science that we do. So you want to make sure it's right. Yes?
So I know that there's, I guess my basic question is like data quality and data manipulation. I'm thinking about how data on police metrics, like you gather your own data on crime in your neighborhood, and this was eventually found that police were manipulating, the districts were manipulating the data coming up so that they would look better, and so the meaning of the data, the quality of the data, as you started producing it, and turned out to feedback to create worse data. I'm just wondering how you think about those issues. What do you do?
Yeah, so this issue of data quality and bias, we work a lot with not just the social scientists and the economists at U Chicago, but with the Harris School of Public Policy. And they're thinking always about, do you really trust the data? I think that's a limitation to some data, so you have to understand, this is one of the reasons for partnering with the city before you look at the data, to understand what that data can and can't tell you, and to sort of ask those questions. Well, how's it gathered? And like with the gang activity, if you didn't know that that was collected based on interviews, you might assign a different weight to it. But interviews are, personal opinions essentially, so it's anecdotal data at best. So this is an issue that I'd say I'm not sure how we can solve that other than including that as an awareness factor in the provenance of the data. But I have seen cases where policy was made based on some anecdotal data and maybe not good on-the-ground data, and that the error of that policy was exposed by looking at data in the Chicago data portal. I'm not going to say what project it was because I don't want to get in trouble, but there was a fairly major social decision that was made, and then it turned out that the Chicago data portal showed that the basis for this decision was wrong. So I think those kind of stories or situations where the data helps you make a better decision or exposes a biased decision are probably going to outweigh the other ones where you see the data is biased and so you sort of take it with a grain of salt. But it's an issue.
How far away do you think we are from having cities that autonomously respond on data with a machine learning algorithm, such as if you have a jammed route of buses, you would automatically reroute all of them into another one, without even human intervention? I just mean about really smart cities. Do you think we're 5 years away or 10?
I'm not really good at predicting the future. I can tell you what's happening now. I'd say where most cities would benefit as a next step is in taking that data and using machine learning or predictive algorithms and telling advising a human what to do. So, as an example, when a car accident happens in a city, it will have an impact not just at that intersection, but it'll have an impact all the way back, a mile or so for a long period of time. So there are things that a smart city, I kind of react a little bit to the whole smart city thing because the premise is often that we can solve difficult problems by adding technology to them. And we all know that that's not true. But there are things that could be done. Take the traffic accident with digital signage, for example. When the accident happens, one could go out from that location and have digital signs route people around that. Those digital signs might be on the back of buses that say, divert this way and only let the buses through, for example. So there are some things that, whether the city can be, making its own decisions, the infrastructure making those own decisions, I don't know, but I think there's huge opportunity, especially with on-the-ground data from sensors, for example, to advise the humans that are running the city. A place where I would say is an example where the city infrastructure could self-regulate, that wouldn't be particularly difficult. Would be I often go to the city. I take the train, and along with thousands of other people, I walk from the train station east into the city. In the afternoon, along with thousands of people, I walk the other way. And I have been in many situations where there are 150 or 200 people standing waiting for a walk sign, and there's maybe one car coming. So if the intersection knew more about the number of vehicles and the number of people, it could adjust its lights so that 200 people aren't waiting for one driver to come through. So there are some things that could be done automatically, but I think the bigger win is to better inform the decision makers.
I asked because I just read a paper. I think South Korea tube station does that. In South Korea, they actually do it where all the work is being prioritized by a computer, and they actually know to do the schedule. And it's only human intervention. They only look at it, and then.
Yeah, so that's an example. The rat example that I showed you is an example of that, where the city can dispatch with a different method that's machine learning informed rather than some other way. So yeah. Paul.
So for how many years has the city been gathering some of the data out of these hundreds of databases? The reason I ask is because with climate studies, one way to partially get a feel for how good is the model is you look at historical weather data, which we have for 100 years. And in your case, you might be able to try out hypotheses of what factors actually do affect what happens to the neighborhood if you have enough historical data.
Yeah, so the city has records. I assume that they go back 100 years in some areas, business licenses and tax receipts and things like that. They have those records. They may be like some of the blueprints on Argonne's buildings hanging in file cabinets on paper. So the question is how much of that data is digitally available, right? There is quite a lot of data going back, I think 40 or more years in education. Steve Raudenbush and others at the University of Chicago, they have all the education data, every student outcomes, et cetera. They can study decades of student performance and things like that. Crime data goes back to 2001. Not that there weren't crime reports before that, but they must be on paper. There are certainly crimes before that. But back to this question about the data, what my public policy friends will say is, that's not crime data, that's reported crime data. That's just the crime that got reported. It's not all the crime. So that kind of background on the data is important.
Thank you very much, Charlie.
Okay.